Hello students, welcome to Competitive Exam Library YouTube channel. Today we are going to see what is the analogous systems, that is particularly for rotational mechanical systems. For this problem we are going to see how to draw the analogous systems. So in rotational mechanical systems we have two types. One is torque current analogy. Next we are having torque voltage analogy. So two types will be there here also. We can take, first let us consider the torque current analogy. So we can take that, then we can write the equations. Before going that, you have to write what is the torque balance equations. For that you have to draw the node basis diagram. Let us draw the node basis diagram for this. So for that you have to see how many displacements, that is angular displacements. There are two angular displacements are there. Let us consider this is theta 1 of t, here theta 2 of t. So for this theta 1 of t, there is one torque is connected. Next there is one moment of inertia is also connected. Between theta 1 and theta 2 you have one spring constant, that is k. For that you have theta 2, you have one frictional coefficient constant, that is b. So we have connected, this is the diagram we have connected for writing the torque balance equations. Let us represent all the terms. Here this is t of t, here the moment of inertia j, here the spring constant k, then here frictional constant b. Let us write the torque balance equations in this. So we can write the torque balance equations. First t of t is equals to, we can write j into d square theta 1 divided by dt square plus k into theta 1 minus theta 2. This is at displacement theta 1 of t. Next at theta 2 of t is equals to, we can write k into theta 2 minus theta 1 plus b into d theta 2 by dt. So this is the second equation. We can write the balance equations at two angular displacements. See, now we will write torque current analogy equations. So you have to replace, the torque can be replaced with the current, that is I of t, then j can be replaced with the capacitor, then k can be replaced with the 1 by, that is inverse of inductance. Next you will have b can be replaced with inverse of resistance. Next you are having, so theta can be replaced with the theta, that is angular displacement, can be replaced with flux. So let us write all the equations here. So theta t of t can be replaced here I of t, then j can be replaced with the capacitor. Next that can be d square phi by dt square plus k can be replaced with 1 by L, theta 1 can be replaced with phi 1 minus phi 2 here. So from Faraday's laws we are already know, V is equals to d phi by dt and d square, that is you take differentiation on both sides, dv by dt will become d square phi by dt square, and phi can be written as integral of v dt. So we can replace these equations in the above equation. We can write I of t can be written as, we can write it as c into dv by dt plus 1 by L integral of v1 dt minus integral of v2 dt. So this is the equation you got. I of t can be written as like this. Next, for the second equation, if you write, that is 0 is equals to k can be, so you can write this equation as number 3. So for the second equation, k can be replaced as inverse of inductance, that is 1 by v2 minus integral v1 dt we can write, plus b can be replaced with inverse of resistance, d theta 2 by theta can be written as d phi by dt. So here you can replace, that can be 1 by L integral v2 dt minus integral v1 dt plus 1 by r into v. This is the fourth equation. So now we can draw the torque current analogy diagram. If you observe all the equations 3 and 4, the voltage, so here voltage is common, capacitor is same, but if you observe the inductor is having two different voltages, that means it is connected between two nodes, we can write. So here C D, we can write that as here d phi 1, here you are going to get, here you are going to get d v1 also. That means for v1 it is connected all the elements. Now here d phi 2, here you are going to get d theta 2, here you are going to get d phi 2, here you are going to get d phi 2, that means here you are going to get v2. So because of this, now we can draw the circuit, that is I of t. By considering that I of t can be connected, you will have two voltages, that is v1 here and that is v2 is here. So for v1 you are having a capacitor is connected for the v1. In between v1 and v2 you have one inductor, that will be 1 by L we are connected, that is a capacitor is connected. For v2 you have one resistor, So this is the, so we can replace with 1 by R here, then it is 1 by L here, then it is a capacitor here, then the torque will be, that is torque can be replaced with the current here. So torque can be replaced with I of t. So this is the torque current analogy, how to draw the torque current analogy diagram. Now let us take torque voltage also. So torque voltage analogy. So in case of torque voltage analogy, so what are the terms can be replaced? So here t of t can be written as, we can write t can be written as v of t, then j can be written as inductor, next k can be replaced with 1 by capacitance, next b can be replaced with r, next displacement, that is angular displacement, theta can be replaced with the charge, angular displacement can be replaced with the charge here. So now you substitute this torque voltage analogy in the equations 1 and 2, then what you are going to get, that is v of t is equals to, we can write j can be replaced with L and d square q by dt square, plus k can be replaced with capacitance 1 by c, theta 1 can be replaced with q1 and q2. So 1 by c into minus q1 into q2. So you know already current is equals to dq by dt, and di by dt, if you take differentiation you are going to get d square q by dt square. I can be written as integral of q dt. So these are the terms you can replace, q can be, so here q can be taken it as d square q by dt square, q can be written as integral I dt. So you can replace this. So in the above equation what you are going to get, L into di by dt plus 1 by c integral of I1 dt minus integral of I2 dt. So this is the equation with replacement. You give the number it as, so I am taking continuation 5. Next equation, So substitute, here only I am writing. So 0 is equals to, in place of k we can write 1 by c integral, just I am writing replacement, that is integral I2 dt minus integral I1 dt, plus in place of b we can write 1 by resistance dq by dt can be written as I is equals to, we can write as I dq by dt you are going to get here, so that can be written as I. So this is the sixth equation. For 5 and 6, so we can write here, so it can be replaced with, if you want you can replace dq by dt also, dq by dt you are already know it as I. So we can write final equation as 1 by c integral of I2 dt minus integral of I1 dt plus 1 by r into I. So this is the equation number 6. For this equations 5 and 6 we will draw the torque voltage analogous system. So let us draw torque voltage analogous system. So if you take torque voltage analogous system in this, so let us write the first equation. For first displacement you are having, so first displacement you are having, there will be two displacements because the two currents are there. Here you are going to get two loops. So first one, for the voltage, the torque can be replaced with the voltage. For this you are having one inductor is connected. So let us see, there is an inductor is connected, that will be di1 by dt only. So one inductor is connected. After that, between I1 and I2 there is a capacitor is connected. So that means you have to connect a capacitor here between I1 and I2. Then you have another element is connected for, that is one will be one resistor is connected for the next current, that is one resistor is connected for the next element. So like this you can connect torque voltage analogy. So you have here 1 by r and you have here 1 by c, here the inductor will be there, this can be E of t. In this you have two currents, one is I1 is connected, another is I2 is connected, where 1 by c is common for I1 and I2, 1 by r is only for regarding to I2. So this is the how to draw torque voltage analogy and torque current analogy for the given system. That's all in this video. If you like this video, please like, share and subscribe the channel. If you have any queries, you make a comment in the comment box. I can reply. Thank you very much.